Hello guys, this is Jacob Sanders, and today we're going to be reading RFC 5234, titled Augmented BNF for Syntax Specifications, also known as ABNF. And this is part of a series that I'm trying to do on YouTube where I read through a bunch of RFCs. To better understand the internet and to become a better programmer in general. Now, these readings are dry sometimes and can get convoluted just because of the nature of how programming specifications and like source code and all sorts of stuff related to computer science can be pretty hard to express in an audio form. So I'll do my best with that. But I still think that this stuff is worth playing in the background. Say you're working out or doing something else and you just want to get exposed to some of this information. Like the way that I see it is like, all right, what this content is good for is for programmers that are serious about learning something. Like say you're like, all right, I'm going to read this RFC if I get time, if I get free time on my own. But I'm also going to just listen to this maybe in the background beforehand to just get my my whole mind like exposed to it and primed, get some of the terminology, get exposed to it, and then when you go and read it yourself, it might stick much better. But like I said, we're kind of in a world of an entertainment marketplace, and this is not going to be probably that entertaining itself, although to me it's pretty interesting stuff because I'm curious about it. But anyways, enough of that rambling expose. Let's jump right into it. So we're going to start with the abstract. I'm going to skip the status of this memo and go straight into the abstract. Internet technical specifications often need to define a formal syntax. Over the years, a modified version of Backus-Naur form, called BNF, or also called Augmented BNF, has been popular among many internet specifications. The current specification documents ABNF. It balances compactness and simplicity with reasonable representational power. This is such a core concept to computer science in general. You want representational power and you want to reduce complexity, and they're kind of like at odds with each other. Anyways, continuing, the differences between standard BNF and ABNF involve naming rules, repetition, alternatives, order independence, and value ranges. This specification also supplies additional rule definitions and encoding for a core lexical analyzer of the type common to several internet specifications. We're going to skip over the table of contents and get into section 1, Introduction. Internet technical specifications often need to define a formal syntax and are free to employ whatever notation their authors deem useful. Over the years, a modified version of Backus-Naur form, BNF, called Augmented BNF, or ABNF, has been popular among many internet specifications. It balances compactness and simplicity with reasonable representational power. In the early days of the ARPANET, each specification contained its own definition of ABNF. This included the email specifications, RFC 733, and then RFC 822, which came to be the common citations for defining ABNF. The current document separates those definitions to permit selective reference. Predictably, it also provides some modifications and enhancements. The differences between standard BNF and ABNF involve naming rules, repetition, alternatives, order independence, and value ranges. Appendix B supplies rule definitions and encoding for a core lexical analyzer of the type common to several internet specifications. It is provided as a convenience and is otherwise separate from the meta-language defined in the body of this document and separate from its formal status. Section 2, Rule Definition. Section 2.1, Rule Naming. The name of a rule is simply the name itself. That is, a sequence of characters beginning with an alphabetic character and followed by a combination of alphabetics, digits, and hyphens, or dashes. Note, rule names are case insensitive. The names, rule name, rule name, rule name, and rule name all refer to the same rule. For those that are Listening to audio, it showed a lot of different case permutations. Unlike original BNF, angle brackets are not required. However, angle brackets may be used around a rule name whenever their presence facilitates in discerning the use of a rule name. This is typically restricted to rule name references in free-form prose or to distinguish partial rules that combine into a string not separated by white space, such as shown in the discussion about repetition below. Section 2.2, Rule Form. A rule is defined by the following sequence. Name equals elements, carriage return line feed, where name is the name of the rule, elements is one or more rule names or terminal specifications, and carriage return line feed is the end of the line indicator, carriage return followed by line feed. The equal sign separates the name from the definition of the rule. The elements form a sequence of one or more rule names and or value definitions, combined according to the various operators defined in this document, such as alternative and repetition. For visual ease, rule definitions are left aligned. When a rule requires multiple lines, the continuation lines are indented. The left alignment and indentation are relative to the first lines of the ABNF rules and need not match the left margin of the document. Section 2.3, Terminal Values. Rules resolve into a string of terminal values, sometimes called characters. In ABNF, a character is merely a non-negative integer. In certain contexts, a specific mapping, in parentheses, encoding, of values. Okay, so in ABNF, a character is merely a non-negative integer. In certain contexts, a specific mapping of values into a character set will be specified. Okay. Terminals are specified by one or more numeric characters, with the base interpretation of those characters indicated explicitly. The following bases are currently defined. B equals binary, D equals decimal, X equals hexadecimal, and hence carriage return equals %D13 and carriage return equals %X0D. Okay, so respectively specify the decimal and hexadecimal representation for carriage return. Yeah, okay, I see. That's what they were just saying, showing how basically you can tell the people reading your ABNF specification what the actual decimal value or hexadecimal value or even binary value is. Okay, so a concatenated string of such values is specified compactly using a period to indicate a separation of characters within that value. Hence, carriage return line feed equals %D13.10. Okay, easy enough. So the period is used as the delimiter. ABNF permits the specification of literal text strings directly, enclosed in quotation marks. Hence, command equals a literal text string, which is equal to the value of command string. Literal text strings are interpreted as a concatenated set of printable characters. Note, ABNF strings are case insensitive, and the character set for these strings is US ASCII. Hence, a rule name equals ABC, all lowercase, and rule name equals A, capital B, C, will basically it's case insensitive. To specify a rule that is case sensitive, specify the characters individually. For example, and here it shows the rule name equaling to %D97, %D98, %D99, where those are the integer values corresponding to the letters A, B, and C. Right, and it shows it in a more compact form where it's %D97.98.99. Okay, so those two examples will match only the string that comprises of the lowercase characters A, B, C, rather than, so it's basically, that's the way that you say that it's case sensitive. Section 2.4, External Encodings. External representations of terminal value characters will vary according to constraints in the storage or transmission environment. Hence, the same ABNF-based grammar may have multiple external encodings. such as one for a 7-bit US ASCII environment, another for a binary octet environment, and still a different one when 16-bit Unicode is used. Encoding details are beyond the scope of ABNF, although Appendix B provides definitions for a 7-bit US ASCII environment, as has been common to much of the Internet. By separating external encoding from the syntax, it is intended that the alternate encoding environments can be used for the same syntax. Section 3, Operators. Section 3.1, Concatenation. Rule 1, Rule 2. A rule can define a simple ordered string of values, i.e. a concatenation of contiguous characters, by listing a sequence of rule names. For example, foo equals %x61, semicolon A. Bar equals %x62, semicolon B. Mumble equals foo bar foo. Right, okay. So that the rule mumble matches the lowercase string ABA. And we can see that it's ABA because foo is equal to the value A, because that's its hexadecimal representation, which it was %x61. Bar is equal to B, and mumble is equal to foo bar foo. And it's a demonstration of the concatenation. Yeah. Okay, so linear whitespace. Concatenation is at the core of ABNF parsing model. A string of contiguous characters is parsed according to the rules defined in ABNF. For internet specifications, there is some history of permitting linear whitespace, which is space and horizontal tab, to be freely and implicitly interspersed around major constructs, such as delimiting special characters or atomic strings. Note, this specification for ABNF does not provide for implicit specification of linear whitespace. Any grammar that wishes to permit linear whitespace around delimiters or string segments must specify it explicitly. It is often useful to provide for such whitespace in core rules that are then used variously among higher level rules. The core rules might be informed into a lexical analyzer or simply be part of a main rule set. Section 3.2, Alternatives, Rule 1/Rule 2. Elements separated by a / are alternatives. Therefore, foo/bar will accept foo or bar. Note, a quoted string containing alphabetical characters is a special form for specifying alternative characters and is interpreted as a non-terminal representing the set of combinatorial strings with the contained characters in the specified order, but with any mixture of upper and lower case. Okay, section 3.3, Incremental Alternatives. Rule 1 equals / Rule 2. It is sometimes convenient to specify a list of alternatives in fragments. That is, an initial rule may match one or more alternatives, with latter rule definitions adding to the set of alternatives. This is particularly useful for otherwise independent specifications that derive from the same parent rule set, such as often occurs with parameter lists. ABNF permits this incremental definition through the construct old rule equals / additional - alternatives, so that the rule set equals alt1 / alt2, rule set equals /alt3, rule set equals /alt4 / alt5 is the same as specifying rule set equals alt1 / alt2 / alt3 / alt4 / alt5. So it allows you to separate alternatives with new lines as long as you have the equals / in the next line and the same token or the same name on the left side. Okay, section 3.4, Value Range Alternatives. %C ###. A range of alternative numeric values can be specified compactly using a dash to indicate the range of alternative values. You see this in regex too, at least in Python. You can do a regex that looks exactly like this. It's like a /x, and then you've got a hex value, and then it's a dash, and then I think it's another /x to escape it, and that's an entire hex range that you can match. So anyways, here they have the example of a range of digits, which is digit equals %x30 to 39. And it's equivalent to digit equals, basically it uses the quotations to list all 9 of these different numbers, basically. Okay, then they say concatenated numeric values and numeric value ranges cannot be specified in the same string. Okay. Numeric value may use the dotted notation for concatenation, or it may use the dash notation to specify one value range. Hence, to specify one printable character between end-of-line sequences, the specification could be char-line equals %x0d dot 09 %x20-7e %x0.d dot 0a. It's interesting that this repeats the %x0d.0a. I'm not sure why you would have both of those in there. It makes sense that you would have this other one because the %x20 to -7e. Okay, well, that's something I probably will need to review a little bit more. Section 3.5, sequence group. Parentheses, rule 1, space, rule 2, parentheses. Elements enclosed in parentheses are treated as a single element, whose contents are strictly ordered. Thus, element, space, parentheses, foo / bar, parentheses, blat, matches element foo blat or element bar blat, and element foo / bar blat matches element foo or bar blat. Okay, this is where reading this stuff could be pretty confusing to someone who doesn't have the visuals here. But how do I explain this? Basically, if you put things in parentheses, it groups them all together. Yeah. But if you put them in parentheses, and I mean you have like the slash, which is like you can use either of them, basically leads to that or that. And then how is that different than this? Yeah, okay, I see. So when you have the parentheses, it allows you to have the front part of the pattern and the back part of the pattern be enforced, but the middle part of the pattern be like branching. And that's why element with the parentheses like foo / bar and then out of parentheses blat can be matched to element foo blat or element bar blat. Whereas like element foo / bar blat can only ever match element foo or bar blat. I don't know if that clarified it at all, but I tried my best. Note, it is strongly advised that grouping notation be used rather than relying on the proper reading of bare alternations when alternatives consist of multiple rule names or literals. Hence, it is recommended that the following form be used. And they have parentheses surrounding element foo, and then they have / and they have parentheses surrounding bar blat. It will avoid misinterpretation by casual readers. Yeah, okay, I see. So basically, even though ABNF allows you to not use parentheses, they're like, use parentheses when things are strictly grouped together so that it's clearer to everyone who reads it that's not like really experienced with ABNF, which I'll let you know, most people probably are going to read an RFC before they read the RFC on ABNF, and they're probably going to be at least slightly confused, or it's going to be ambiguous what it is really specifying. Okay, so moving on to the next section. Section 3.6, variable repetition, star rule. The operator star preceding an element indicates repetition. The full form is A * B element. Weird. Where A and B are optional decimal values, indicating at least A and at most B occurrences of the element. Oh, okay. So if you had 1 * 2 foo, then you would have 1 foo or 2 foo, whatever foo actually ends up being. Right, foo might be like %x 30, which is like 0, I think. So you would either have 2 zeros or 1 0. I don't know if that was clear. Moving on. So default values are 0 and infinity, so that star allows any number including 0, and 1 star requires at least 1. 3 star 3 allows exactly 3, and 1 star 2 allows 1 or 2. Okay? That's kind of similar to Python too. Python uses the star symbol to basically, you see it with star args, and it's basically saying we just took everything that was positional, which could be any number of things, and we put it all in here. Also in Python, you can do in the language, you can take a list and you can do something like star list, and it'll basically unpack that entire thing. So it's almost like a reverse of this. So section 3.7, specific repetition, n rule. A rule of the form n element is equivalent to n star n element. That is exactly n occurrences of an element. Thus, 2-digit is a two-digit number, and 3 alpha is a string of 3 alphabetic characters. Okay, so alternatively, you can just put a number in front of whatever you want, and it'll be exactly that number of those things. Optional sequence. This is represented as bracket, rule, bracket. Square brackets enclose an optional element sequence. Bracket foo bar bracket is equivalent to star 1 parentheses foo bar parentheses. And yeah, that's pretty straightforward. If you see brackets, it means it's optional. 3.9 or section 3.9, comment. Semicolon, comment. A semicolon starts a comment that continues to the end of line. This is a simple way of including useful notes in parallel with the specifications. Okay? Section 3.10, operator precedence. The various mechanisms described above have the following precedence from highest, binding tightest, at the top to lowest or loosest at the bottom. Rule name, comma, pros val, comma, terminal value, comment, value range, repetition, grouping, comma, optional, concatenation, alternative. Use of the alternative operator freely mixed with concatenations can be confusing. Again, it is recommended that the grouping operator be used to make explicit concatenation groups. Section 4. ABNF definition of ABNF. Notes. 1. This syntax requires a formatting of rules that is relatively strict. Hence, the version of a rule set included a specification in a specification might need pre-processing to ensure that it can be interpreted by an ABNF parser. So the second note is this syntax uses the rules provided in Appendix B. Rule list is equal to 1 star parentheses rule slash parentheses star C dash WSP C dash N1 end parentheses end parentheses. Man, this is going to be really hard to make sense of. Let's see, rule equals rule name defined as elements C dash NL colon continues if next line starts colon with white space. So those are the comments, I guess. Rule name equals alpha space star alpha or digit or a dash. Defined as equals any number of the CWSP element. I'm going to start not reading what it actually is in the ABNF, like symbols, and instead trying to interpret it correctly, because that's more audio friendly. So defined as equals any number of the name C-WSP, and then followed by an equals sign or an equals and a slash, followed by any number of a C-WSP name, and then there's the comment. These are the basic rules definition and incremental alternatives. And then we go down to the next one. So the name elements equals an alternation and a star CWSP. So and any amount of CWSP. a C-WSP is equal to a WSP or a C-N1 WSP. What is a WSP? Do they have a WSP here? Oh. Looking for a CWSP. I think it stands for white space. Okay, C-NL is equal to a comment or a carriage return line feed. A comment is equal to a colon, followed by any number of white space and or VCHARs, followed by then a carriage return line feed. Yeah, okay, this is all starting to make sense to me. Alternation is equal to the concatenation, or is equal to a concatenation, followed by any number of C-WSP, which is basically any number of white spaces and carriage return line feeds and or comments. So anyways, I'm going to stop going through this, but I'm going to leave the link for this. If you want to take a look at that, I think it's a pretty interesting. It's really cool that ABNF can describe itself with itself. That's a pretty interesting thing. Let's go into section 5, security considerations. Security is truly believed to be irrelevant to this document. Okay. Section 6, references. We got some references here for various different things. Then we have the acknowledgements. This ABNF was originally specified in RFC 733 by Ken L. Herenstein. Okay. And there are some more people in this document that are given some credit in the acknowledgements. And then we've got the Appendix B, which is the core ABNF of ABNF. This appendix contains some basic rules that are in common use. Basic rules are in uppercase. Note that these rules are only valid for ABNF encoded in 7-bit ASCII or in character sets that are a superset of 7-bit ASCII. Certain basic rules are in uppercase, such as SP, HTAB, or space, HTAB, carriage return line feed, digit, alpha. And then it's going to go through here and define what all of these things are that you're going to probably see in ABNF. These are sort of like in Python, you have like the built-in data types. These are kind of like the ABNF built-ins. You don't worry about them. There's nothing custom about them. They're just explicitly stated here, and you can rely on this specification. Like, this is what it is. If you see alpha, it means it's basically of the hex value 41 to 5A or 61 to 7A, which is basically equivalent to the letters capital A to Z or lowercase letters A to Z. A bit is the value 0 or 1 in quotations, and a char has its hexadecimal here too. So you can just see all the values for all this stuff. Oh, this was what I was trying to find. I was guessing on what is WSP. And WSP is the comment says it's white space, and it's made up of either a space or an HTAB. Yeah, so very interesting. All right, cool. So that's basically this RFC 5234 titled Augmented BNF for Syntax Specifications, ABNF. So this has been pretty educational for me. Obviously, I'm probably going to still be learning more about this as I encounter it in the wild. But it's been useful to go over this. I hope it was useful for you as well. If you want to continue trying to learn about programming and come along with me on some of my readings, or check out some of the projects that I'm sharing or personal code that I use to solve different problems. I'm going to have a lot of stuff on this YouTube channel, I think. Time will tell, but the plan is to have a lot of stuff. And of course, my shameless plug at the end, if you want to check out my programming blog, it's at pieharbor.com. I don't think there's going to be a one-to-one for all of my videos because it's hard to write articles as fast as you can record a video. But I'm going to probably be doing a bunch of articles as well. And, I'm going to be trying to grow the blog, how much content it has, in a similar way. But the main focus is always to learn. That's the main focus. So thanks for joining me.